Although the Bousquet de Mange 75 and DB-10, twin-engine aircraft with twin tail booms and wide-lifting fuselages, were created in 1925, for aviation enthusiasts, the name Brunelli is forever associated with aircraft of this configuration. This name is known to everyone, even in France, when it comes to aircraft with a fuselage that generates lift. On June 5, 1930, Brunelli's aircraft made its first flight with 20 passengers on board. This occurred more than 6 months after the Dyle et Bacalan company built a giant tri-motor aircraft designed to carry 28 passengers. In 1924, the head of the Dyle et Bacalan Design Bureau, engineer Laton, developed an amazing flying machine. The unique feature of the aircraft was its habitable fuselage section, which effectively formed a thick and large wing section. This twin-engine combat aircraft, DB-10, though it flew, behaved quite clumsily in the air. This aircraft was presented at the 1926 Paris Air Show and existed only as a single example. However, the idea found its continuation. In 1926, the steady growth in passenger numbers prompted airlines to approach aircraft manufacturers with a request to develop planes that could transport 30 to 50 passengers comfortably for extended periods, regardless of the time of day. Junkers in Germany and Fokker and Ford in the USA were working seriously on this task. Based on the experience gained during the creation of the DB-10, engineers Laton and Foucault, using previous developments, designed a new aircraft called the DB-70. The project was a large tri-motor aircraft with a significant passenger capacity for its time. It was intended to carry 28 people per flight. In November 1926, the first wind tunnel tests were conducted at the Eiffel Laboratory. For testing, the aircraft model received a specially designed wing from the Dyle et Bacalan company. This wing consisted of a thick central section with a low aspect ratio and 2 lateral panels that maintained a constant width along their entire length. The test results, presented in a report dated December 10, 1926, were quite promising. The maximum aerodynamic efficiency of the wing was 15.7. Soon after, aerodynamic tests of a scale model of the DB-70 began, the results of which, as the report indicated, were not entirely satisfactory due to problems with the tail assembly. Engineer Laton asked the laboratory staff to remove the tail assembly and resume testing. A report dated June 18, 1927, which supplemented the previous data, noted, to avoid degrading the wing's flight characteristics, the tail assembly needed to be modified. At the end of 1927, a wooden aircraft model, wingspan 36.5 inches, length 19 inches, with the new tail assembly was tested in the Eiffel Laboratory to verify aerodynamic balance. According to a report dated January 27, 1927, the aerodynamic efficiency was 13.0. Numerous tests then followed concerning the deflections of a flap attached to the trailing edge of the central wing section. During these tests, it was determined that, with the flap in its normal position, the aircraft's behavior did not change. However, when the flap was deflected upwards, the aircraft experienced slight instability, which was compensated by increasing the area of the fins. Having obtained satisfactory test results, the Dyle et Bacalan company began construction of the aircraft at its factory in Bordeaux at the end of 1928. Construction was carried out by a team of workers and technical specialists under the supervision of Messrs. Schwint, Richer, Labonnigue, and workshop foreman Gaillard. Due to a lack of space, the aircraft assembly was carried out in a rented hangar at the Marignac airfield. The aircraft's wingspan, which was approximately 121 feet, did not allow it to be assembled in the standard position. Therefore, the machine had to be rotated parallel to the hangar doors. This decision also significantly complicated maneuvers when rolling the aircraft out of the hangar, and rolling it back in. Step by step, the gigantic aircraft took shape. Soon the engines were installed on the motor frames. 3 V-shaped 12-cylinder liquid-cooled Hispano-Suiza aero engines with a 60-degree bank angle. These engines, newly certified in the second half of 1928, developed 600 horsepower each at their nominal operating mode. Although the aircraft was designed for a full load weighing approximately 28,660 pounds, the safety margins, confirmed by static tests, allowed for considering an increase in the maximum takeoff weight to approximately 35,274 pounds. Naturally, provided more powerful engines were installed. In September 1929, while the aircraft was still being assembled, the aviation department of Dyle et Bacalan was absorbed by Newport Delage. This occurred as part of a government policy aimed at consolidating the aviation industry. Following the acquisition, the aviation department became a subsidiary of Société Aérienne Bordelaise, or SAB, whose general director was appointed Engineer Laton. In mid-October, the DB-70 model, with its main and tail landing gear struts mounted on special trolleys, was rolled out of the hangar doors. To ensure the rollout process was as safe as possible, 2 parallel narrow-gauge railway tracks were laid, along which the aircraft was moved using a crawler tractor. Engine tuning began immediately under the supervision of Monsieur Listener, seconded to SAB from Hispano-Suiza. Following ground checks of the engines and subsequent taxiing, on November 15, 1929, under the command of Chief Pilot Charles de Camp, the first flight of the DB-70 took place. Loaded with 396 gallons of fuel, 317 pounds of oil, 423 pounds of water, and 1,764 pounds of ballast placed in the rear of the baggage compartment, the enormous aircraft, with a total weight of about 23,149 pounds, lifted off the runway after a takeoff run of approximately 197 feet. At this moment, all 3 engines operated at reduced revolutions, 1,100 revolutions per minute. Besides the pilot, the crew of the first flight included 3 mechanics, among whom were Glory and Bonnard, as well as 2 passengers: Albert Math, a representative of the French Aviation League, and Pierre Marie, a reporter for the publication Ailes. After 4 minutes, the aircraft reached an altitude of about 3,281 feet, and then flew over the river and the city of Bordeaux at an altitude of approximately 4,101 feet. For several minutes, the DB-70 was escorted by Potez 25 and Breguet 19 aircraft. Half an hour later, the gigantic aircraft landed in Marignac, majestically appearing before engineers Laton and Foucault, who witnessed this historic flight. Despite the absence of brakes, which were planned for later installation, the DB-70's rollout distance was short. Leaping from the newly stopped aircraft, de Camp enthusiastically shared his first impressions of the flight. "This aircraft glides magnificently. It possesses flight qualities unmatched by other machines today. The aircraft holds steady in the air while remaining highly maneuverable. Its speed will be high, as it has an excess of power and an enormous speed range." In the following days, this enormous aircraft took to the sky several times. During one of the test flights, Henri Boucher, the editor-in-chief of L'Aéronautique magazine, was present at the airfield. Soon after, he, along with SAB's general director, Engineer Laton, made a 40-minute flight on the DB-70. Pilot de Camp lifted the 11-ton aircraft, weighing approximately 24,250 pounds, to an altitude of 50 meters, or approximately 164 feet, and demonstrated how easily it performed maneuvers, which was astonishing for such a massive machine. After the first flights, minor changes were made to the tail assembly design. Subsequently, on November 21st, the DB-70 made a 12-minute flight, and on November 24th, a flight lasting 15 minutes. At the beginning of the last week of November, 2 reporters from Paramount Company came to Marignac to film the takeoffs and landings of this giant aircraft. 4 flights were organized for them, 2 on Tuesday, November 26th, and 2 more the following day. Thanks to good weather, the filming was exceptionally successful. Madame Suzanne Deutsch de la Meurthe took advantage of her stay in Marignac to take a seat aboard the aircraft and participate in one of the 2 flights that took place on Tuesday. She described her impressions in one word: wonderful. Despite delays due to fog, tests continued throughout December. For example, on December 12th, the DB-70 made 2 flights, and on Thursday, December 14th, this aircraft, with a maximum takeoff weight of 13 tons, lifted off the runway after a takeoff run of 120 meters and a duration of 12 seconds. In 5 minutes and a few seconds, it reached an altitude of 1,000 meters. The aircraft's high aerodynamic characteristics and its gliding capability slightly increased the landing roll length, as the brakes had not yet been installed at that time. The aircraft then encountered bad weather and remained grounded until mid-January. Then, taking advantage of good weather, the DB-70 added several flight hours to its logbook. Until this point, the aircraft had flown with an open cockpit and a cabin not adapted for passenger transport. Only in February was the machine sent to the hangar for refitting. During the refitting, the cockpit received glazing with a high ceiling and sliding side windows. Additionally, seats were installed in the passenger cabin and auxiliary facilities were equipped inside the fuselage, outside the main cabin. The aircraft received toilets and kitchen equipment. On May 8, 1930, the fully equipped aircraft took to the skies again. Charles de Camp was able to conduct factory tests by the end of May. After this, the machine was sent to Villacoublay for official testing under the supervision of a special aviation technical service. But what exactly was the DB-70 from a technical perspective? The DB-70 was a huge 3-engine monoplane with a strut-braced wing and an unusual load-bearing fuselage. The fuselage frame consisted of high-strength steel and duralumin was also used for the skin. The central element of the aircraft was undoubtedly its load-bearing fuselage. It was effectively a wing section with a thickness of 2.40 meters, a span of 8.56 meters, and a chord length of 10.20 meters. In the middle of this section, which had a biconvex profile, like an aerodynamic wing, was the passenger cabin measuring 4.90 by 2.88 meters. Inside the passenger cabin, there were no complex trusses or tension rods, making it spacious and comfortable. 4 main beams, made of strong steel, formed the central part of the aircraft. They were arranged parallel along the wingspan and further reinforced with duralumin compartments. Along the aircraft, this central section had a height of approximately 6 feet 1 inch and a depth of about 7 feet 6 inches. Viewed cross-sectionally, it consisted of 5 compartments, separated by 6 ribs that precisely matched the wing's shape. Of these 6 ribs, only the 2 outermost ones were internally reinforced with special lattice trusses. All metal elements of the central section's structural framework were connected by large metal brackets, ensuring its ideal rigidity. The outermost stiffening ribs of the central part of the aircraft were connected to 2 additional rectangular section beams. Each of these beams had its own robust base, consisting of 4 spars and bulkheads. This solution allowed these 2 beams to significantly reduce the loads on the central part of the aircraft. Thanks to special tail booms, torsional loads did not affect the central part of the aircraft. This allowed for a rather large passenger cabin to be placed inside without the use of additional structural strengthening elements and without compromising the aircraft's strength. This structural feature made it extremely attractive for use as a passenger airliner or a spacious ambulance aircraft. In the forward part of the aircraft's central section, 3 engines were installed, each in its own nacelle. The 2 side engine nacelles were quite short, while the third, located with the pilot's cockpit, was positioned centrally on the aircraft. 2 widely spaced tail booms allowed for the installation of a very efficient stabilizer on the aircraft, featuring 2 main beams and a significant span. Its span reached approximately 44 feet, and the chord length was about 5 feet 8 inches. The pilot could adjust the stabilizer's angle of incidence using a special self-braking worm gear mechanism. The stabilizer moved relative to its rear main beam. This mechanism was developed in Paris by the company Dyle et Bacalan. The horizontal empennage had 1 elevator, which was fully balanced. A large fin was installed in the aft part of each tail boom, to which a balanced rudder was hinged. The entire empennage was all metal, with metal skinning, except for the elevator and rudder skins. The aircraft's wing consisted of 2 halves, or panels. They had elliptical tips, and their width remained constant throughout their length. The wing generally had an aspect ratio of 6.74. To ensure good lateral stability, each wing half was slightly raised upwards at an angle of 3 degrees, and the lower surfaces of their tips were additionally raised. A medium thickness aerodynamic profile was used along the entire length of these wing halves. Its lower part was flat, which simplified production. The width of the wing halves, chord length, was approximately 15.75 feet, and their thickness was about 2 feet. Each wing half had a robust structure, the basis of which was 2 large duralumin box spars. These spars were connected to each other by numerous light metal transverse beams. These beams served as support for the stringers, longitudinal elements, to which the metal skin sheets, forming the wing's surface, were attached. The wing halves were attached to the central part of the aircraft using special connections that linked the upper spars of the central part to the tail booms. In addition, the wing halves were further reinforced by 2 pairs of streamlined struts. One end of these was attached to the wing spars, and the other to the same connections that joined the lower spars of the central part and the tail booms. The main landing gear struts were also attached to these same connections. The ailerons, which had a large aspect ratio, were equipped with a special compensation mechanism. Thanks to this, the forces the pilot applied for control were never greater than those required to pilot a 2-ton aircraft without such a mechanism. This made control significantly easier. To reduce unwanted air resistance between the front part of the aircraft's central element and the propellers, the Hispano-Suiza engines were placed as far as possible from the lift-generating fuselage. 2 bulkheads were installed between each engine and the passenger compartment, one for fire protection, the other for sound insulation. A passage located between the engines and the fuel tanks allowed a mechanic to perform minor repairs directly during flight. This could involve replacing spark plugs, resolving fuel supply issues, or changing oil filters. Lamblin radiators, which were metal plates located on the engine cowlings, provided oil cooling. Water cooling radiators were installed directly in the airflow beneath the engines. 2-bladed fixed-pitch propellers were made of wood. A fuel capacity of approximately 740 gallons allowed the aircraft to remain airborne for up to 9 hours at nominal engine operation. Fuel was stored in 4 main tanks. 2 of them were located in the front part of the aircraft's central element. and another 2 were in the rear part, in the cargo compartment. During flight, access was provided to all parts of the aircraft's fuel system, including shutoff valves. The aircraft's main landing gear struts were fixed. They did not retract in flight. The track width between the wheels was about 22 feet, and there was no central axle between them. Each main strut was installed vertically beneath the outer side planes of the tail booms. It had dual wheels measuring approximately 43.3 by 8.66 inches and was supported by a V-shaped brace. This brace was made of high-strength steel and attached to the lower spars of the aircraft's central section. The connection between the dual wheel hub and the main landing gear strut's front rod was provided by an oleopneumatic shock absorber, which absorbed impacts during landing. This landing gear strut is similar to the type known today as crosswind. Each pair of wheels was mounted on a ball joint, allowing them to move along a vertical axis. This solution enabled the strut to deviate slightly from the course during aircraft taxiing if there was a crosswind. Additionally, the crosswind strut featured mobility perpendicular to the hub line along the horizontal axis, ensuring simultaneous contact of both dual wheels with the surface during angled landings. In such a case, each pair of dual wheels returned to its initial position using an elastic mechanism. The tail supports, attached to the rear parts of the tail booms, were steerable. In this huge aircraft, its creators thought of everything to ensure maximum comfort. The central cabin and 2 side cabins had a total living area of about 323 square feet. The ceiling height, which was almost 6 feet 2 inches, allowed passengers to move around freely. The passenger cabin could be accessed via a hatch and ladder located in the lower rear part of the aircraft's central section. The path led through the rear baggage compartment and a corridor. On either side of the corridor were a small galley on the right, where light snacks could be prepared, and convenient wash basins on the left. The corridor ended at the entrance to the central passenger cabin. Its large dimensions, approximately 16 feet 1 inch by 9 feet 5 inches, allowed for the arrangement of a full-fledged lounge with 2 tables and 8 chairs. Through side doors from the central cabin, one could access the side cabins located in the tail booms. Each of these cabins accommodated 10 chairs, divided into 2 rows by a central aisle. The side cabins and the central cabin were skillfully decorated and adorned with luxurious carpets. Partitions were embellished with modern paintings, and wicker furniture created the feeling of being on a comfortable yacht. In front of the cabins and the lounge was a passage that allowed passengers to admire the views through 6 large glazed windows located in the front part of the aircraft's central section. In the rear part of the central cabin, on either side of the corridor, were baggage compartments with a total volume of about 353 cubic feet. Daytime lighting was provided by 7 windows on each side of the tail boom and ceiling portholes. At night, the passenger cabin was illuminated by ceiling electric lights. Heating and ventilation of the cabin were ensured by the circulation of air, which was drawn from outside and then heated as it passed along the engine's exhaust manifolds. As mentioned earlier, this layout was designed for a day passenger aircraft intended to carry 28 people with 88 pounds of luggage per person. The total passenger luggage weight was about 2,469 pounds. In the night airliner variant, the aircraft's passenger capacity was reduced to 24 people. 16 passengers slept in the side cabins and another 8 in the central cabin. Each compartment contained 2 rows of 4 chairs, which were easily transformed into 2 section couches. The aircraft designers considered using it as a medical transport. This aircraft could accommodate 20 wounded individuals lying on adjustable stretchers. 4 in the side compartments, and 12 in the central cabin. The stretchers were to be arranged in 2 tiers, with a distance of approximately 29.5 inches between them. Between adjacent stretchers were passageways about 19.7 inches wide, allowing personnel to move freely. Loading the wounded was planned through special doors located on the side of one of the 2 tail booms. To create doors approximately 6 feet 2 inches by 7 feet 4 inches, engineers had to remove part of the structural frame elements at that location. The ambulance aircraft was also to be equipped with a system for lifting and conveniently distributing stretchers throughout the compartments. The considerable space freed up in the central cabin could be used for a wardrobe, and the galley could be converted into a small bar. In addition to the recumbent wounded, the aircraft could additionally carry, without overloading, 4 seated patients, a doctor, and a nurse. With a fuel reserve for 6 hours of flight, each wounded individual could take about 66 pounds of luggage with them. For its time, this aircraft was very well equipped with diverse, quite complex equipment. The cockpit, with side-by-side seats, had dual controls that could be engaged or disengaged using a special mechanism. The view from the cockpit was excellent, even after it was fitted with a roof and sliding side windows at the factory following the first tests. A rather simple instrument panel was located between the seats and was clearly visible to both pilots and the flight engineer. His workstation was in the crew corridor, located between the passenger cabin and the aircraft's glazed nose section. The flight engineer's task was to monitor the engine's operation, as well as fuel and oil consumption. This work was facilitated by a well-equipped instrument panel. In addition to the main panel, the flight engineer's workstation also had an auxiliary engine that powered the starting compressor, an emergency generator, and the fuel distribution system. The navigators and radio operators' workstations were located in the middle of the crew corridor, in a bulge at the level of the cockpit. A full set of navigation equipment allowed flights even at night. The radio operator had a radio receiver and a radio direction finder at his disposal, which were installed in a separate insulated compartment. Communication between crew members was quite easy thanks to the corridor, which all workstations opened onto. In addition, there were doors specifically for the crew at each end of the corridor. Factory tests were successfully completed. On May 30th, 1930, the aircraft, piloted by Descamps, took off from Merrimack Airport. On board the aircraft were 23 people, 4 motorcycles, various equipment, and about 1,102 pounds of luggage. After a flight lasting 2 hours 45 minutes, the aircraft landed in Villacoublay, where it was preparing for extensive trials under the supervision of the State Flight Institute. On June 8th and 9th, during the National Aviation Days held at the Proving Ground near the French city of Vincennes, this large tri-motor aircraft had the opportunity to fly over crowds of Parisians who had gathered for the celebration and looked up. Undoubtedly, the flight of this giant made a strong impression. In the following days, the aircraft was sent to the hangar, where variable pitch propellers were installed. Descamps spent July and August 1930 adapting them. Presumably, the results of these tests were unsatisfactory, as fixed pitch propellers were reinstalled on the aircraft. In late August, Descamps began load tests. However, the modifications to mail planes in Bordeaux distracted him. Constant trips from Bordeaux to Villacoublay and back slowed down the testing of this large tri-motor aircraft. Nevertheless, in September, during a flight with a maximum weight of almost 31,000 pounds, the aircraft climbed to an altitude of almost 12,140 feet. Even a slight overload did not prevent it from accelerating to 112 miles per hour. At that time, a large passenger aircraft from the German company Junkers caused considerable excitement. In late October, Decamps used flights over Paris to demonstrate that France also had its own giant aircraft. Tests then continued, with pilots from the Stia company already in the cockpit. At one point, the management of Société Aérienne Bordelaise planned to send this aircraft on a major European tour after the completion of tests. But unfortunately, it never went beyond the planning stage due to its large size and also because it was still in the testing phase. The aircraft did not participate in the Paris Air Show held in November 1930. As a result, visitors who came to the Grand Palais were forced to settle for just a large-scale model. Although beautifully made, it could not replace France's largest aircraft at the time. On February 11, 1931, after completing all tests, the aircraft accelerated in 11 seconds, took off from the ground, and, under Decamps' control, departed from Villacoublay. Despite terrible weather, the flight to Mérignac proceeded without incident. During the flight, a 5-hour test was performed, which concluded without any problems. Flights continued in Mérignac. On May 28th, the director of SAB Company, Monsieur Leton, invited prominent figures from the Bordeaux region to participate in a demonstration flight. The deputy mayor of Bordeaux, Monsieur Marquet, deputy Monsieur Laurent, as well as numerous military personnel and representatives of civil authorities, had the pleasure of flying over the city aboard this aircraft. On Wednesday, April 1st, at 10 p.m., a night flight demonstration took place. During it, Decamps performed 3 successful lighthouse landings. While the aircraft was in Mérignac, it was made even more comfortable by enlarging the windows in the fuselage. In August 1931, the aerial giant returned to Paris for certification by Bureau Veritas, which successfully registered it as a passenger aircraft. After the European tour of Junkers aircraft, even the most short-sighted minds began to worry about the accelerated growth of passenger aviation in neighboring Germany. They asked themselves, even disregarding the warlike and treacherous nature of our neighbor, why is this civilian fleet being created, which is perfectly suited for military purposes in case of conflict? The French Air Force became very interested in the idea of using civilian aircraft for military purposes and decided to test it in practice during the East military exercises in September 1931. General Claudel, who commanded the exercises, contacted the Ministry of Aviation. It immediately placed at his disposal the DB-70 aircraft, at that time the only certified high-capacity commercial aircraft. On September 7th, under the corresponding order, the aircraft was requisitioned at Mérignac Airfield. On September 9th, after a test flight, the aircraft took off and landed in Reims in 5 hours. Immediately upon arrival, with 14 officers on board, the DB-70 aircraft performed a demonstration flight, executing a series of maneuvers. It is worth noting that these flights during the exercises were far from tourist excursions. On September 11th at 5 p.m., a special Air Force unit of 20 combatants under the command of Captain Geneste was loaded onto the aircraft. They were ordered to notionally destroy several targets behind enemy blue lines. Decamps transported the unit to a parachute drop zone near Attigny. During the night, the commandos attacked a lock at Givet, a railway bridge over the Aisne River, the bypass canal from Rilly to A, and army fuel depots. All these objectives were notionally destroyed. The following day, at 7 a.m., Decamps and his aircraft picked up the commandos near Beaumont Farm, and by 8 a.m. they had landed in Reims. Following the success of the first operation, Generals Weygand and Claudel decided to use the aircraft and the commando unit in exercises again. On September 15th, in the afternoon, the DB-70 aircraft departed from Reims in the direction of Chalons-sur-Marne. Approaching at low altitude, at 5 p.m., The aircraft landed in a clearing near Michaud. The commandos quickly disembarked from the side cabins located in the tail booms. The landing was so swift that the minister and generals present did not even have time to follow the entire operation. While the DB-70 aircraft was heading back to Reims, the commando unit began an approximately 9-mile march through the undergrowth. After completing the march, the unit attacked and notionally destroyed a regiment that had left its deployment location in Betheneville. Based on the results of these two operations, the command recognized the effectiveness of a new type of combat operation, which, unfortunately, high-ranking officials quickly forgot. As for the DB-70 aircraft, after the maneuvers concluded, it was returned to the company and resumed its more peaceful activities, participating in a long flight over the fields of Champagne where the Minister of War, the Minister of Aviation, as well as Generals Weygand, Claudel, Chabert, Girard, Barrès, Divernet, Michaud, Ergo, and Pelli Marchetti. However, the record number of generals with their stars and epaulets on board the aircraft during this approximately 62-mile route could not claim registration with the International Aeronautical Federation. Having demonstrated its excellent flight and operational qualities during maneuvers, the aircraft returned to Bordeaux, making stops in Bourges and Poitiers along the way. However, the DB-70 aircraft was delayed for a short time in Marignac. The probable reason for this was the assembly process of the heavy bomber AB-20, which at that moment occupied not only the thoughts and efforts of SAB company management, engineers, and workers, but also the space in the hangar where the DB-70 usually stood. In early December, the DB-70 aircraft returned to Villacoublay. It was piloted by Decamps and Engineer Lieutenant Jouy. On December 15th, this aircraft became part of a large-scale exhibition of prototypes organized for members of the French Parliament, deputies of the Chamber of Representatives, and senators. The delegation was led by the Minister of Aviation, Monsieur Albert Caquot, as well as Generals Pelli Marchetti and Féquin. In the following days, the President of the Republic visited the exhibition. He expressed admiration for the new machines, particularly singling out the DB-70 among over 100 aircraft presented. Afterwards, representatives of the aviation press were allowed to inspect the prototypes. Decamps took the opportunity to show experienced journalists how magnificent the Palace of Versailles and its surroundings looked from a bird's-eye view. Decamps performed 2 flights, each time taking more than 20 people on board. The passengers, having never before seen André Lenotre's creation from such an angle, were impressed by the intricate patterns of the Versailles gardens. After such a successful end to the year, the DB-70 aircraft flew to the provinces for the New Year holidays. In late January 1932, it was again delivered to Villacoublay, where, under the guidance of Lieutenant Jouy, the machine was demonstrated to military pilots from the new aircraft group. In September 1932, this large 3-engine aircraft, as part of the aforementioned group, participated in military exercises held in Champagne. In early 1933, it was returned to Marignac. In September 1933, the DB-70 finally participated in an official aeronautical sports event, the 3rd flight of prototype aircraft across the cities of France. On September 9th, the caravan of aircraft from the National Aeronautical Federation took off from Orly. However, the giant SAB company aircraft joined the other participants only on September 11th in Bourges. Poitiers, Saint-Brieuc, Abbeville, Arras, Douai, Reims, Metz, Epinal, Belfort, and Troyes saw this heavy 3-engine machine land at their airfields. On September 17th, The flight concluded with its return to Orly. By this time, the three-engine aerial giant had honorably endured all possible and impossible trials it had been subjected to. Unfortunately, a suitable application for which the DB-70 could have qualified due to its characteristics was never found, neither among civilian airlines nor among the military. Ultimately, in December 1933, the aircraft was sent to the Heavy Aircraft Pilot Training School located in Versailles, where its career came to an end.